the Spike2 graphical sequence editor. From the sample pull-down, we can access the sampling configuration. Here I have set up one waveform channel and two event channels to record. To access the graphical sequencer, we use the Sequencer tab. On the screen is the underlying software code that is the sequencer, a set of instructions to control waveform and digital outputs. The highlighted code is a loop, pulsing the digital and waveform outputs high and low. In this example, we can start the outputs by pressing the character A, shown here. The set command controls the execution rate of the sequence. In this example, each command is performed every 1000 milliseconds. Programming the sequencer can give you very fine control, but for most people, the graphical version is just what they need. With Graphical Editor selected, we can again control the execution rate in milliseconds. Try to keep the rate as low as possible for your needs, as more processor time needs to be allocated at faster rates. In the Graphical Editor display, we might want to see times in milliseconds, so set that here. Likewise, we might want to scale our waveform outputs. Changes are made on the right. In the Outputs to Display section, we can switch digital and waveform outputs on or off. Now we'll enter the Graphical Editor. The new display is resizable and shows the output channels on a time track. The current section is called Initial and plays the outputs as soon as sampling starts. In some circumstances, this is not required, so many users treat Initial as the null or halt output state. As you can see from the drop-down, Initial is accompanied by 26 other output sections. The blue line in the window is called the control track. This holds icons representing condition and marker information. Clicking on the control track, we can enter a key, which the section will react to, and start its output. Changing from the Initial section to key A, adding a Go key for this section, setting the number of times this section will repeat. If set to 0, the section will repeat indefinitely. Here, under the control track, a label shows the duration of the frame. An output section can be up to 10,000 seconds in length, but there are limits to the number of pulses you may produce. To get around this, you can set a frame to repeat for the number of pulse repetitions you require. From the palette on the left, we can select icons representing pulses and add them to the timeline. Adding a single pulse to one digital output here. Now a train of pulses to the other digital output line. As each pulse section is added, or later clicked on, we can edit its parameters. Start times and length are the most usual, but amplitude for waveforms, and here, the interval between the number of digital pulses can also be set. Now a pulse shape suitable for only waveform channels, a ramp. We can set the start and end amplitudes, and for a sinusoid, the amplitude and phase. In the palette, you can see other types of pulse shapes available to add. If pulses are placed on top of each other in a DAC channel, the result would be a summation of the two shapes. However, if the absolute levels checkbox is selected in the editor settings page, then the output level is set by the last item in the overlap. Define here where the sequencer is to go after 5 repeats of this, the current section A. We can link the end of this section to key B, which would start immediately section A finishes. To save time duplicating outputs in multiple frames, we can use the copy function here. Choose which outputs to copy, including the control track. Now choose the source or start and the range or single key section to copy to. Copying from key A to B. As we view key B, we should see only the digital outputs copied from section A. Stepping between the two sections to see the differences. It should now be easy to drag the train of pulses to a different time in the output frame. Now that the pulses are correct, we can look at the lower palette items. These control track icons allow us to wait for a condition, branch if necessary, and add markers to the data file. We can also employ variable arithmetic. Adding the wait icon to the control track. By default, this gives us a random delay. We can specify the range of time, min and max, in seconds to choose a time from. Other options include waiting for a waveform channel condition, such as above or below a level, as well as detecting a single new digital input or burst of events. With the control track selected, we can change the length of the output frame, as well as the number of repeats and where the sequencer should go when the frame is finished. Choosing Initial here, so that the outputs stop at the end of key B's output. Allocate a keyboard character to the section so that we can start it independently at any time. The comment added here will appear while sampling to help us remember what this section does. Closing the editor stores the currently defined outputs ready for sampling. Pressing Run Now takes us immediately to a new sampling document. What we see here is a dockable sequence control panel. Start recording, then press one of the sequencer keys to start the output. With key A, we see 5 repeats followed by an automatic link to key B. Pressing key B now, just one instance of this output happens. Instead of pressing the control panel item, we can also use the keyboard. Note that the whole section of output is not played, as the sequence was told to restart too quickly. Now pressing H to halt the whole sequence. To add an arbitrary waveform, we can use either existing data or create our own. Here we will explore the use of virtual channels. Give the new channel a sampling rate. Here I'm copying the rate of the recorded waveform, but you can also enter your own frequency. Clicking on the arrow button to the right opens a list of virtual channel functions. Selecting sinusoid from Generate Waveform, we can set a frequency and time to align the zero crossing to. The waveform is now computed and displayed. Accessing the channel expressions again to add an envelope to the sine wave. Setting the rise, plateau and fall times for the envelope. And a new expression is formed. This is added to the virtual channel expression. At this point, it does not compute. Adding multiply by to the expression will cure this. What remains is a tone burst of waveform. To add this wave to the graphical sequencer, we need to use the output waveform section from the sample pull-down. We specify the channel, time range to add, and which DAC output the wave will be sent to. Add a label and a key. Press Add. Now added to the arbitrary waveform list, we can go back to the graphical editor. On section key B, we will add the palette icon for the arbitrary waveform. A small marker appears in the control track and the waveform is shown on output DAC 0. Having changed the length of the output, we can see the whole wave shape that will play. Let's test this output. Selecting output key B, tone burst waves are now played alongside the digital outputs. To initial, or halt, now forces all of our outputs to a known state. Adding the branch icon to the control track, we can set a probability percentage to either continue to the end of the time track or branch to a new key. Set 50% and a destination of key B to repeat this output or continue to the end and branch to key A. Testing the output. The outputs are now random. Back to the graphical sequencer now. If on section key B we add a sine wave after the arbitrary waveform, you can see that there are allowed and disallowed placement areas. Add a digital pulse now, and a timing error is produced. This is indicated by a small tick here and also a message in red. By changing the time of the pulse, we can remove the error, or we may be able to change the sequencer rate to improve resolution. That's it for this brief introduction to the graphical sequencer. I do hope it has given you some ideas.